Then base fold is an adaptation of FRI for multilinear, and then FRI Continued is an adaptation of FRI for binary fields. Well, that's like the landscape.
So most of them are really on FRI.
A lot of them, yeah. Yeah. A lot of them. Even stare and wear are like variations on FRI. We could. Not yet, but we could. We could. When you understand the other ones deeply. So all we have done so far is like the commitment phase for FRI. So we still need to do the query phase. Like how do we prove the consistency across different layers? But any questions so far?
All the data that is gotten from all these stuff, it's saved on the blockchain, right?
No, wait though. This is not related to blockchain at all.
Like the data that all these things we kind of like bring out that needs to be saved and stuff like that. Where do they go?
Wait. What do you mean saved?
Okay. Now, huh? so we have so we collect user information, for instance.
Okay.
We want to apply maybe this kind of logic. ZK to it to kind of hide those user information and stuff. So if we're able to run the computation to perform those stuff, those user information will still be saved somewhere, right?
So we will the user now. Like you're trying to hide that. Imagine like your financial data, for example, and you're trying to prove that you're credit worthy, right? You're trying to prove that you're credit worthy. It means that you want to go through all your debits and credits.
Yes.
I mean, there's an algorithm that can determine whether you're credit worthy or not.
Yeah.
So now that algorithm would run locally with the user's information locally, but then it would generate a proof of that computation that it is running. So it's basically like you have created a circuit that can take all the debits and credits, and then the output node will return either 1 or 0. 1 meaning that the person is credit worthy, or 0 meaning that it's not. So you can imagine implementing that circuit with GKR, right? And then the user is the prover. You, the person that wants to give the loan, is the verifier. Both of you have the same circuit. You just don't have the input layer of the, which is the user's information. So the user will now put that their data as the input layer, then run the GKR protocol to generate the GKR proof. Now the GKR proof does not have the user information because you don't send the inputs. You have done like your multilinear KZG commitment, which is just like a group element that is standing in place of the entire users. So once that proof is done, it sends it to you. Now you never need to see the user's data, but you know that the user cannot lie about like the computations. Exactly. And then you can now verify that.
In this case now, you are explaining GDR with case, meaning we've removed the inputs.
Yes. I'm explaining with a polynomial from next game.
Yeah. But like in the normal, the previous
so it's not ZK.
Okay.
But even right now, even with the multilinear case, it's still not fully ZK because of every layer you're kind of like sending the
evaluations
of WRB WRC, which is giving a hint as to what is in the circuits here. So there's a way to hide values still, while still preserving.
Still do without sending those ones.
No, you send it, but you send it with a blinding factor. So it's like you're adding it's like you have a painting and then you just throw sand on it, so that if someone looks at it, they can't really see it, but then the underlying structure is still there. So you can still do like your alpha times this thing plus beta times this thing and still be able to get like your results, but you can't see the true value anymore.
Well, would start like can't reason that like using generator
Can't what?
like encrypting
Encrypting.
this stuff would that work?
Possibly. It hides things while still preserving the structure. But using generators are slow. People are moving away from using ellipticals. Yeah.
Well, that's why you said KCG is old.
It was and it's still so still has the shortest proofs. So it's still the thing that's kind of like being used in prod right now after they do the recursion. But people are moving. Right?
But they are all still the same concepts.
It's still just PCS. It's still just a polynomial content scheme. That's all. We good? Alright, now let's end here. So tomorrow. Yeah? Are you guys are you still?
No.
Can you still?
No. I have personal questions. Just waiting for
So tomorrow, the lady from PSC